So students, we discussed the concepts of linear programming in the previous class, and today we are going to discuss questions of a little bit higher level. This is first one. Determine graphically the minimum value of the objective function z equal to minus 50x plus 20y, and these are the constraints. Now, how do we solve this linear programming problem? The first constraint is 2x minus y is greater than or equal to minus 5. The second constraint is 3x plus y is greater than or equal to 3, and the third constraint is 2x minus 3y is less than or equal to 12, and x is greater than or equal to 0 and y is greater than or equal to 0. These two constraints are always given to you. So the very first thing that you have to do is you will write the equation corresponding to this linear inequality. It will become 2x minus y is equal to minus 5. We would like to write it in intercept form. That means we will divide both sides by minus 5. 2x divided by minus 5 minus y divided by minus 5 is equal to minus 5 divided by minus 5. So x divided by minus 5 by 2 plus y divided by 5 will give you 1. So another inequality is 3x plus y is greater than or equal to 3. So 3x plus y equal to 3 will be the corresponding equation to this linear inequality. Divide both sides by 3. 3x divided by 3, y divided by 3, 3 divided by 3, x divided by 1, y divided by 3 equal to 1 is another equation. Third one is 2x minus 3y is equal to 12. Divide both sides by 12. X divided by 6 plus y divided by minus 4 is equal to 1. Now, what do? We will draw the graphs of these inequalities on a single graph sheet. And this is y-axis. This is x-axis. X dash, y dash. On x, minus 2.5, on y 5, 1, 3, 6 and minus 4. That means the maximum value on x-axis to be plotted will be 6, and on the y-axis will be positive 5 above the origin and minus 4 below the origin. So we will mark these points as 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, 5, 6, 7, 8, and here it will be minus 1, minus 2 and minus 3. First is x divided by minus 2.5 and y divided by 5. X पे minus 2.5 and on y-axis we'll have 5. As I told you earlier that we have to write the equation on this line 2x minus y is equal to minus 5. And let us check the region that will be represented by this inequality put 0 comma 0 here. 0 plus 0, 0 is greater than or equal to minus 5. Yes, that means the region towards the origin is to be shaded. Next one, x by 1 and y by 3. On x axis you have to take 1 and on y axis you have to take 3. This is 3x plus y is equal to 3. Put 0 comma 0 in this inequality. 0 plus 0, 0 is greater than or equal to 3. No. So the region away from origin is to be shaded. Next, x by 6 and y by minus 4. y पर minus 4 चलना है. And on x-axis you have to mark 6. The equation that is being represented by this line is 2x minus 3y is equal to 12. Check the region that will be represented by this inequality. Put 0 comma 0. Is 0 less than or equal to 12? Yes, that means the region towards origin is to be shaded. So, and these two inequalities mean first quadrant, right? So the region below this line, this side and this side is to be shaded. So this is the region that is to be shaded. This is the region which is the common solution of all these linear inequalities constraints. And what do we call it? We call it the feasible region. Feasible region. Right? Now we will mark the corner points, because at the corner points the objective function will have either maximum or minimum value, and we have to find the minimum value. So this is point A with coordinates 6 comma 0. This is point B with coordinates 1 comma 0. This is point C with coordinates 0 comma 3, and this is point D with coordinates 0 comma 5. So we will put all these points in the objective function, and we will check which is the lowest of all those values. So put A, that is 6 comma 0 in Z, and Z is minus 50x plus 20y, so it will be minus 300. Now point B is 1 comma 0. If you put it in Z, that will be minus 50. C point is 0 comma 3. Put it in Z, and that will give you 0 comma 3, 60. And point D with 0 comma 5. In Z, it will give you 100. So what is the minimum value of Z? The minimum value of Z will be minus 300. Okay, let me tell you, this is the lowest value, right? Had the region been bounded, then the lowest value of Z would have been the minimum value of Z. But if the region is unbounded, that is why I said that this is a question of good level. If the region is unbounded, then the lowest value of objective function Z may or may not be the minimum value of Z. It may or may not be, right? Had it been bounded region, then the lowest value would have been the minimum value and the question was over. But if the region is unbounded, so you have to pay attention to what I am going to tell you now. If the region is unbounded, then the lowest value, this lowest value may or may not be the minimum value. It may or may not be the minimum value of Z. So to check whether this lowest value is minimum value of Z or not, what we have to do is we will take the objective function. We will take the objective function and see, we'll check whether minus 50x plus 20y less than minus 300, right? This is the lowest value of z. We'll check whether this objective function minus 50x plus 20y can have a value which is less than minus 300, right? So we will write the corresponding equation and then we will plot it on the graph. Corresponding equation will be minus 50x plus 20y is equal to minus 300. 0 cancelled out. Minus 5x plus 2y is equal to minus 30. Divide both sides by minus 30. So minus 5x divided by minus 30 plus 2y divided by minus 30 is minus 30 divided by minus 30. X by 6, y by minus 15 is equal to 1. Now we will plot this equation on the same graph sheet, but as it had only less than and not equal to. So what we do is the graph will be a dotted line. It has to be a dotted line. It has to be a dotted line. On x we'll move 6 and on y we'll have minus 15. X is 6, y minus 15 will be somewhere here. Let us take it as this one, right? On x we'll have 6 and on y we'll have minus 15. Now we will check the region that is to be represented by this inequality. Take 0 comma 0, 0 plus 0 less than minus 300. Is 0 less than minus 300? No. So the region towards origin is not to be shaded. The region away from the origin is to be shaded, right? So this will be the region away from origin. And the solution of this inequality is called open half plane. Open half plane, or you can simply call it solution of the given inequality. If the solution of this inequality and the feasible region have some common points, which is there in common in this question. So if the solution of the given inequality and the feasible region have some common points, then this minus 300, the lowest value of z, is not the minimum value of z. And we will discuss it. Why did I say this? So we will say as the solution of given inequality, which we call open half plane, and the feasible region have common points. So minus 300, that is minus 300, which was the lowest value, is not the minimum value of z. And we can say, therefore, under the given conditions, there is no minimum value of z. Now I'll tell you the reason behind it. I'm saying that I wish to find the region where this objective function minus 50x plus 20y will attain a value which is less than minus 300. So in this region, this objective function will attain a value which is less than minus 300. That means in the feasible region, other than the corner points, there are some points where this z will attain a value which is less than the lowest value. That means इस region में जो ये blue and white वाला है, इसमें जो common region है, इसमें there are so many points for which z will have a value which is less than minus 300. That means the objective function will not have any minimum value under the given conditions. Hope it is clear, and this is a very important concept. See, this is the solution that is given in NCERT. This was the feasible region, and this is the open half plane. It has common points, so in this region, this objective function will attain a value which is less than minus 300. That means under the given conditions, there is no minimum value for the objective function. Right? So if the region is bounded, then at corner points, whatever value we get, maximum is maximum, minimum is minimum. But for unbounded region, we have to do this additional step. Another question of same type. What is it? Minimize z equal to 50x plus 70y. Z equal to 50x plus 70y, it is to be minimized, and the constraints are 2x plus y is greater than or equal to 8, x plus 2y is greater than or equal to 10, and x and y are greater than or equal to 0. So what we do is, we will first write the corresponding equation to these constraints. 2x plus y is greater than or equal to 8, and x plus 2y is greater than or equal to 10, and x and y greater than or equal to 0, that means first quadrant. The equation corresponding to this inequality will be 2x plus y is equal to 8, 2x divided by 8, y divided by 8, 8 divided by 8, x by 4, y by 8 is equal to 1, and the next one is x plus 2y is equal to 10, x by 10, 2y by 10, 10 by 10, x by 10, y by 5 is equal to 1. This is the intercept form of the second equation. Now we will draw the graphs of these inequalities. For that, we'll have this as x-axis, so this is the y-axis, and this is x-axis. X dash, y dash. On x, the maximum value that we have to mark is 10, and on y, the max value is 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, and 8. On x, mark 4, and on y, mark 8. On y, we'll mark 8. On x, we'll mark 4. On x, we have to mark 4. So it will be somewhere here. Write the equation, that is 2x plus y is equal to 8. The region that is to be shaded will be, let's take 0, 0 is 0 plus 0 greater than or equal to 8. 0 greater than 8 is not correct. So the region away from the origin is to be shaded. Next one, x by 10 and y by 5. On y we'll mark 5 and on x we'll mark 10. Write the equation, that is x plus 2y is equal to 10. 0, comma 0, does it satisfy? No. So the region away from the origin is to be shaded. And these two inequalities mean first quadrant. So region above this line, and in first quadrant this is the feasible region. Now the region is unbounded. चलो उसको बाद में देखेंगे. Let us first mark these points. Point A is 10, 0. Point B will be 2, 4. Seems to be correct. 2, 4. And point C will be 0, 8. If you are not able to locate this point B, 2, 4, then you have to solve these equations to get the point of intersection. But if you think that is 2, 4, then put these two coordinates in this equation and in this equation, where if they satisfy, that means this is the solution. 2 into 4 plus 4 is 8. 2 plus 8 is 10. So this is the solution, that is point B, coordinates of point B. Now next you will put A, that is 10, 0 in Z. Z is 50x plus 70y, that is 500. Point B, that is 2, 4 in Z. 2 into 50 is 100. 4 into 70 is 280, that is 380. And C, point 0, 8 in Z, 560. So this is the lowest value of Z, but as the region is unbounded, that means this lowest value of Z may or may not be the minimum value of Z. So for that, what do we do? As we did in previous question, we will write 50x plus 70y, the constant, if it is less than 380. So 0 cancelled. 5x plus 7y will write as 50x plus 70y equal to 380. 5x plus 7y equal to 38. Divide both sides by 38. X divided by 38 by 5 plus y divided by 380, ठीक है, by 38 by 7 इक्वल टू 1. ठीक, तो ये कुछ आएगा x डिवाइड बाई 7.4 ना 7.6. plus y around 5.4 is equal to, as the inequality has only less than, so the line will be dotted, x 7.6 and y 5.4. It will go somewhere like this. So this is the line which represents this equation. We have to write the equation: 50x plus 70y is equal to 380. The region that will be represented by this inequality, let us take 0, 0, 0 plus 0 less than 380, yes. So the region towards the origin to be shaded, and that too in only first quadrant. So this is the solution of this inequality, that is open half plane. It means this objective function z can have value less than 380 in this region. That means in the feasible region there is no point which can give the objective function a value less than 380. What does that mean? It means that the feasible region and the open half plane, the solution of this inequality is called open half plane. The feasible region and the open half plane don't have any point in common. That means the lowest value of z is the minimum value of z, right? As the feasible region and solution of given inequality, which we call open half plane, don't have any common point. So the minimum value of z is 380 at point, what is that? B, that is 2, 4, right? And this is the solution that is given in NCERT. This is the feasible region. This is feasible region, and this is open half plane. There is no common point in the feasible region and the open half plane. That means the lowest value of z is the minimum value of z, right? So these two questions were of the type where the feasible region is unbounded, and in the questions involving unbounded regions we have to draw this dotted line which is represented by 50x plus 70y less than 380, and the solution we already have discussed. Now there is another question, this another concept rather. The question says this is the question, and then I will show you this one as well, whatever I'm hiding. Find the points to maximize the objective function, that is z equal to 60x plus 40y, and these are the constraints. The first constraint is 1000x plus 1200y is less than equal to 9000. 12x plus 8y is less than equal to 72, and x and y are greater than or equal to 0. So the equation corresponding to these inequalities, 1000x plus 1200y is equal to 90,000. 1000x by 9000, sorry, plus 1200y so it will give you x by 9 plus y by 90 by 12 equal to 1. X by 9 plus 6 cancels it. X by 9 plus y by 15 by 2 equal to 1. Next one, 12x plus 8y is equal to 72. 12x by 72, 8y by 72, 72 divided by 72. We got the two linear equations in intersect form. Draw the graphs. This is y-axis and this is x-axis. Origin x, x dash, y, y dash. On x, the maximum distance you have traveled is 9, and on y, the maximum distance you travel is also 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On x, we have to mark 9, and on y, 7.5. On y, 7.5, and on x, 9. Okay. Write the corresponding equation. That will be 1000 x plus 1200 y is equal to 9000. Put 0 comma 0. Satisfies? Yes. So the region towards origin is to be shaded. Next, x by 6 plus y by 9. X by 6 and y by 9. On x, it will be 6, and on y, it will be 9. Write the corresponding equation. 12x plus 8y is equal to 72. Now, check the region that will be represented by this inequality. Put origin here. 0 is less than 72. Yes. So the region towards origin is to be shaded. And this is the first quadrant. So what is the feasible region? So we have corner points as 0, 0. A will be 6, 0. C will be 0, and 15 by 2. B will be 9 by 4 and 45 by 8. B is 9 by 4 and 45 by 8. How did we get it? By solving these two equations. The solution will be 9 by 4 and 45 by 8. So these are the corner points which can give you the maximum and minimum values of Z. But there is a twist in this question, right? Put O 0, 0 in Z. What is that? 60x plus 40y, it will be 0. If you put A 6, 0 in Z, it will be 360. Point B 9 by 4 and 45 by 8 in Z, it will also give you 360. And point C with 0, 15 by 2 in Z, it will give you 300. We have to find the maximum value of Z. So the maximum value of Z is obtained at point A and at point B. So can we say that at point A and at point B, at both these points, the objective function Z has the same maximum value? So do we have to write that both these points give the maximum of Z, or the answer will be something else? This point you have to remember, which is very important, that if at 2 points the maximum value of Z is same, then at all points which lie on the line segment joining point A and point B, at all these points the value of Z will be same, and that is 360. So how many points are there in this feasible region at which objective function Z will have maximum value of 360? Because at A and B 2 points Z attains the same maximum value. So not only at these 2 points, but on the whole line segment joining A and B, the maximum value of Z will be the same, that is 360. So what will we write? We will write that as at A, that is 6, 0, and B, that is 9 by 4 and 45 by 8, maximum value of Z is 360. So at all points lying on line segment joining A and B, Z will have maximum value. So this point, as I said earlier, is important, that if at 2 points Z attains the same maximum value, or if we have to find minimum, same minimum value, then not only at A and B, but on all points which lie on line segment AB, Z will have its maximum value. This question, this concept can be asked in subjective question like this, or this may be asked, or this has been asked in board's examination in MCQs as well, right? Okay. Now there is another question that I have framed, and that says find the points with integral coordinates, right? It's nowhere in any of the books, but we have framed it for you because you may get some new questions in examination, right? So find the points with integral coordinates to maximize this objective function Z. Now integral points, you will say that 6, 0 are integral coordinates, but B has non-integral coordinates. So will only A be the answer? No. Will A be the only answer? No. What we'll do is, if you draw it on the graph sheet, then you will observe that A point is 6, 0, another point will be 5, some fraction, next point will be 4, 3. See, X is 6, 5, 4, 3, 2, 1 and 0, and for these find Y. So when X is 6, Y is 0. When X is 5, Y will be in fraction. When X is 4, 4 into 12 is 48. 48 goes that side. 8Y equal to 72 minus 48. 8Y equal to 24. So Y equal to 3. That means a point with integral coordinates which lies on line segment AB is A, that is 6, 0, that is already there, and there is another point 4, 3. Right? If you put 3, then in place of X, then Y will be some fraction, 2 will be some fraction. So only another point which has integral coordinates other than A, that is 6, 0. So the answer will be points A, that is 6, 0, and point B with 4, 3 are the 2 points with integral coordinates which give us the maximum value of Z, and that is 360. Yes. And these two types of questions which I discussed in today's video, these questions are very important, so you should practice these questions before you go for your examination. And from my side, this chapter, this topic is over. Thank you.